When we talk about AI, we obsess over the sheer scale of the models and their raw reasoning benchmarks. We assume that when an agent completes a complex task, the model itself is doing all the physical and temporal heavy lifting. In reality, a language model is a stateless engine. It takes the text placed immediately in front of it and predicts the next best decision. It has no active memory of what happened 5 minutes ago. It has no digital hands to type a command, and no eyes to check a screen to see if a file actually opened. A highly intelligent model without surrounding architecture is completely paralyzed. It requires an invisible software layer called a harness to transform static intelligence into dynamic agency. At the center of this architecture map, the model sits in total isolation, responsible for exactly two things: reasoning and deciding. Before thinking, it needs briefing. The harness uses context injection to deliver past conversations and instructions directly into its working window. While the model decides the next step, the harness steers the workflow using the control mechanism. If a conversation gets too long, the harness runs a compaction routine to summarize history so the context window doesn't overflow. It also manages Ralph loops, forcing the model to repeatedly tackle a problem until it succeeds. The model dictates what to do next, but the harness acts as the steering wheel that keeps the operation from derailing. Once the model decides on a plan, it hits a physical barrier. It cannot type a command into a terminal or pull data from an external service on its own. In the action layer, the harness executes bash commands or API calls on the model's behalf, then captures the real-world result, like an error or past test, feeding it right back into the model's context. Without this return loop, the model would be acting blind, unable to course correct or know if the commands it asked for actually worked. Clicking submit isn't the same as succeeding. A model shouldn't blindly assume a form went through just because it sent the command. Through the observe and verify function, the harness captures browser screenshots or pulls system logs, giving the model a way to visually confirm the outcome of its action. But even a self-correcting agent faces the challenge of time. If a system restarts 3 hours into an 8-hour task, how does the agent remember its place? The persist layer solves this by writing state data to the file system, or Git, creating a permanent memory that survives beyond a single active session. By forcing the system to check its work and record its progress, the harness upgrades a fragile text generator into a reliable worker with object permanence. A physical harness is designed to channel a powerful but completely undirected force into useful, controlled labor. Raw reasoning is a powerful but undirected force. The engineering of the harness is what channels that energy into autonomous, multi-step work. If you deploy two identical, state-of-the-art models, their reliability will differ entirely based on the strictness of the architecture around them. One will verify every move, while the other drifts into broken states. Scaling models is only one part of the equation. The engineering of the harness determines if an agent reliably completes a job or collapses into a broken state.